morning, good afternoon, good evening, wherever you are or at what time you're watching this video. Today I want to show you how to test for a short in a motherboard. And for every technician out there, when you are repairing a motherboard, you need to know how to test whether you have a short in the motherboard. And that's exactly what I am going to show you right now. The first thing you need to understand is how to use your meter in this digital multimeter. And I hope you can see my meter is off. I turned it off. And so when you want to test whether there's a short, you turn your meter into the resistor mode or diode mode, or in other words it's called peeping mode. And that is the peeping mode. I hope you can see we have something like a bell there, bell icon. You have the diode alongside with it. This is a sign of a diode, so that's why we call this diode mode or resistance mode. And also the beeping mode, this is where this is the calibration which you use to test whether there is a short in the motherboard. So once you turn your meter that way, then the first thing you need to verify, you can see you have so now in my meter there are two probes. We have the black probe and the red probe. So these are the meter probes. So once I touch these probes against each other, you can see there is a beeping sound. I hope you can hear that sound. And there is that light, this LED. You can see a steady light and a steady beeping. And you can read the resistance is 0.00.00, right? So that shows this point is connected to the other point. So this is like a baseline. This is the baseline of a short. So whenever when you're testing the motherboard, that's the reason we first verify the baseline. So we know our baseline is 0.00, right? Then inside the motherboard we have what's called the circuit. So when you see a coil like this one, for example, this is a coil, this is a coil. So these are inductors, or in other words coils. We have capacitors, we have ICs, we have MOSFETs, right? So whenever you see a coil, for example this one, this coil, so this is a circuit by itself. Around this coil we have this coil, we have capacitor. I have a certain this a MOSFET, then a MOSFET. So I have two MOSFETs, a coil and a capacitor. I have a coil, two MOSFETs, capacitor. So that's the coil by itself. That's a circuit by itself. For this one, for this circuit, I have a coil. I have an IC here. I don't know whether you can see it. There's an IC here. This flat component. This IC, and then you have a few capacitors around it. So this is a circuit by itself. You have a coil. You have a MOSFET, the capacitor. So this is a circuit, and even these very small capacitors. These are ceramic capacitors, multi-layer ceramic capacitor. They are normally called the MLCCs. Then you have another coil here, two MOSFETs. We have capacitors around there, some of them. So these are circuit by itself. When you see a coil, a few MOSFETs or an IC, that capacitor, that's a circuit. A coil, inductor, capacitor, the few capacitors, that's a circuit by itself. So you can find out this inductor, for example, this inductor in a MOSFET, they serve this RAM slot. Maybe another one serve the other one. I'm not saying exactly this one serve this or this. So what I mean is every circuit, for example, if it is this one, it's serving something. So when you see a circuit, there must be something which is being driven by that circuit, or that circuit is supplying power to that something, right? I don't know whether you can get it. Yeah, for example, we have this one. So what I know for sure, this one, this is a circuit be supplying the pseudo bridge of the CPU. Then you have another circuit supplying the CPU itself, or this one, I don't know which one is which. Then you have also the charging circuit. So whenever you have any component, so you have a circuit serving it, right? So let's go straight to our business today. So we have set our baseline is 0.00 because we've placed the probes against each other. Then so we've seen our baseline for the resistance. So now what to do now, we want to test where is the short. So I will put my plug probe against the ground of the motherboard, and we say the ground is every screw hole is the ground, or this metallic, you can see. So once I touch anything which is ground, my meter will read 0.00, or it will beep. You can hear that. So I will know that's a ground. There's a ground. You can pay attention to the readings as well as the beeping sound, right? So in addition, again, every circuit, there's no way the circuit is connected to the ground. So when we want to test whether there is a short, we will place our red probe against every inductor. For example, let's start with this one. You can see this one, there's no beeping, and I have a 1.114 ohms. So there it means I don't have the short. There is no short there. Let's see this one. There I have 1 point something again ohms and no beeping. So it means still there is no short. So when I say there is no short, I mean there is no short within this circuit. What about this one? Still I have 0.745 ohms, so that's amount of resistance here. So still I don't have a short. And testing the inductor, you can put your probe any side of the inductor, either the other side or this side. Then there, after there, we can test this one. Do you hear that, guys? You see, just a very small peep, then it stopped. So it means there is no short, despite the fact that there are some a few resistance, but still no short. That's not a short. The short is the one which peeps continuously like that one. There is a short. But if it's just a single peep, there is no problem with that. And again, even if you can hear the peeping, you also need to verify the resistance. If it is almost zero, or if it is zero, that will be a short. Sometimes your meter might not peep, but you need to pay attention to the reading, guys, right? So like that one, you see, you can hear that. There's no short because you can see the resistance, just a peep. That's not continuous, so that's just a resistance from the CPU. Then again, there's something else I want to show you here. These coils, these coils which serve the CPU, for example this one. So I believe this is the coil now serving the CPU. You can hear, guys, it's peeping continuously. So you might think there is a short, but no, there is no short. Why? This coil serving the CPU, it has some resistance from the CPU. That's why, because a CPU is it's like a motherboard within the motherboard. This inside this one, there are micro components inside it, right? You can hear. So you might feel like there's a short here, but no. So to verify that, you can see the resistance. It's 4 ohms, meaning I don't have a problem there. I said my short should be 0.0. or 0.001, or the homes which is almost to 0. But this one, these are 4 homes. That's not a short, right? Yes. What of this one? That's 0.6. That's 6.1. Still, there is no short there. So meaning this circuit is okay. What of this one? Still, here I have no problem. You see, 12.7. So it means again this circuit is very okay. What of this one? Nothing, right? Yes. And that's how you can measure whether every motherboard behaves the same. So I can't say this motherboard is different from the other motherboard. All of them. For example, I have another motherboard here. So let's use this one for few illustrations. I have another motherboard here. This also HP motherboard. 840G is 840G3. There is another motherboard. So let's again try to see whether, so this is the ground. We want to test to confirm the shorts. So this is the circuit which is going directly to the CPU. You can see this track here. So this is the CPU. So meaning this circuit supplies the CPU with power. You see, we have 5.1 ohms. So that's the resistance from the CPU. Despite the fact that there's beeping, but still there's nothing like a short. So that line is not shorted. 5.1 still to the CPU. That line is not shorted. What of this one? I don't know. Yeah, this one. Yes, there. Still no short. What of this one? Still no short. So when I say this one, I meant when once I test this coil, this inductor actually generalizes the entire circuit. So if there is no short, it means all these components are okay. If one of them fails, it will short the power to the ground, and this entire circuit will be shorted. So if this circuit is shorted, can you? So there's no short there. That one pip is not a short. So this entire circuit, if it is shorted, the others, this one would not be shorted. So when you have a short here, it doesn't mean it is transmitted to the entire motherboard. The only problem is when you have a short here, that power is shorted to the ground. So meaning there's leakage of power. And if there's leakage of power, that power might be channeled towards the CPU or channels toward wherever this supply is going. And if whatever this supply is supplying that power to, if that component, for example, if this channeling power the CPU, and the power which will come out of here is maybe 3 voltage, and then there's a short here, there will be a linkage of maybe 19 excessive power being channeled to the CPU, and that will explode this CPU, and that will be the end of that motherboard, right? Yes. Again, that's I believe I have explained. I know I might not have covered every detail you needed to know, but at least I have shown you how to narrow down the short in the motherboard. Yes. For example, this one, when in case I had a short here, for example, this circuit, so which there is no short. So if there was a short here, it means either these capacitors are shorted. You can hear one side is the ground, the other side is not the ground. So meaning this side is where the power is being channeled through. This is the track of the power. So if there was a short at this, if this coil was beeping against the ground, I would have known maybe I have a short among these capacitors. One of them is shorted, or this IC is shorted, or whatever this circuit is applying power to is shorter, right? Yes, well, that's what you need to understand, and that's the basic and shortest way the shortest way to narrow down the short in the motherboard, right? Yes. So guys, thank you so much. And in case you have any question, you can just put it down in the comment section. Then I can either answer you through there, or I can consider making a video explaining your question, right? So thank you so much, guys, and see you in the next video. And have a blessed and a wonderful, wonderful, wonderful day. Bye bye. See you next time. And please, guys, subscribe to my channel, share with your friends, and just put a like there. I'll appreciate so much your comments. Yes, please subscribe to my channel, and yes, thank you.